Organic chemistry is a major branch in chemistry, and it studies compounds that contain carbon. Carbon is a super special element, number 6 on the periodic table, number 1 in our hearts, and the reason it's so special is a number of things. First of all, carbon can form 4 bonds. In fact, it has to form 4 bonds, and not many other elements on the periodic table can do that. In addition, the bonds that carbon form are really stable, and carbon can also form either single bonds, double bonds, or triple bonds. And to the best of my knowledge, it's the only element on the periodic table that can do that. Now, organic compounds, as I said, contain carbon in conjunction with just a handful of other elements. Hydrogen, for example, also nitrogen, oxygen, phosphorus, sulfur, and then the group 17 elements called the halogens. It's not very many elements on the periodic table. If you're checking things out, it's a handful, really. And so it might surprise you to know that there are more organic compounds in the world than there are inorganic compounds, so compounds made from everything else on the periodic table. Just the way and the multitude, I guess, of ways that these compounds can form gives organic compounds that edge. Now, as I said, organic chemistry is now defined as chemistry, carbon chemistry, it's often called. It was once defined as, an organic compound was once defined as compounds found in living things or things that were at least once living. So here we have our DNA bases, adenine, thymine, cytosine, and guanine, all containing carbon in conjunction with some nitrogen, some hydrogen, got some oxygen in there. Clearly DNA bases found in living organisms. However, that definition had to change when a scientist synthesized this particular element. This is urea. And urea maybe sounds a little bit familiar. It's found in urine. So why a scientist decided that would be the compound that he was going to synthesize, I'm not too sure. But that was it, and scientists said, well, hey, if this can be synthesized, which means man-made, we have to change our definition. This is an organic compound containing carbon there, but it's not found in something living, or that particular sample wasn't found in something living. Okay? Organic compounds are super, super important. Perhaps this is the most important organic compound. This, guys, is caffeine, which keeps a lot of us going throughout the day. Now, as I said, organic compounds all contain carbon, but that's not a two-way street, so it doesn't work the way that all compounds containing carbon are organic. So there's some exceptions that you guys need to be aware of. For example, oxides. So carbon monoxide, carbon dioxide, neither of those are organic compounds. As well, when carbon forms a polyatomic ion like carbonate or cyanide, not an organic compound. And finally, if on the rare occasion carbon forms an ionic compound, so usually it bonds with a metal, that's not normal for it to happen, but it does occur. In those cases, those would be not organic compounds. So those would all be inorganic compounds. So key thing to remember, there are a handful of exceptions to carbon-containing compounds that are not organic. Now, under the umbrella of what makes an organic compound, we can split that off into two branches. Hydrocarbons, compounds containing, surprise, just hydrogen and carbon, and hydrocarbon derivatives, and that's when the other elements, nitrogen, oxygen, phosphorus, sulfur, and the halogens get involved. So you can see there's many, many different types or classifications of organic compounds, and I don't even have all of them on there. Under the part of hydrocarbon derivatives, there's at least 4 more categories or more that I can think of. So if you go on in organic chemistry, you still have lots to look forward to in terms of finding out about new and different and exciting compounds. In our course, all we're going to take a look at are hydrocarbons. So again, as I mentioned, those are compounds that contain just carbon and hydrogen. Seems to be pretty simple. Why are hydrocarbons important? Fossil fuels, okay? That's where they come from. So when we're getting oil out of the ground, we are getting a big mixture of hydrocarbons. Oil is responsible for running basically world economies, countries' economies. Perhaps it's responsible for your parents' jobs. Perhaps someday you will be working in a field that deals with fossil fuels, oil, and gas. So these compounds, as I mentioned, hydrocarbons contain just hydrogen and carbon, and when you guys get to work with our molecular model kits, you'll be making models just like these. It's called a ball and stick model. So the white balls here, those represent hydrogen, and the black ones represent carbon, and you can see how they all get together. By the end of this particular unit, you guys will be able to name both of these compounds up here on this display. We're going to start our investigation of hydrocarbons by talking about alkanes. And really, before we get into talking about alkanes, we need to talk about the prefixes that are used. Okay? Alkanes are hydrocarbon compounds that contain only single bonds between carbon, and of course only single bonds between carbon and hydrogen, because hydrogen can only form one bond. This system of prefixes here, guys, is super important. Not only do we use it to name alkanes, we use it to name everything in organic chemistry. It's a brand new way of counting to 10. Let's take a look at how that works. If there is, one carbon present in a compound, the prefix that you would use for that compound would be meth. No, that's not like methamphetamines. This is not an episode of Breaking Bad. Just keep it under control. If there are two carbons contained in the compound, the prefix would be eth. 3 is prop. 4, I know it looks like but it's pronounced bute. 5 is pent. 6 is hex. 7 is hept. 8 is oct. 9 is non, 10 is dec. Now what I always get asked here is, are we going to have this on a test? No, you're not going to have it on a test. The goal will be that you guys do enough examples before a testing situation that you know these prefixes cold. What I like to do is I like to count to 10 using these organic prefixes, which are a little bit different than other prefixes maybe you've learned before. So if we count to 10 using our new words, we have meth, eth, prop, bute, pent, hex, hept, oct, non, and dec. Again, those prefixes are going to be used over and over and over, not simply just for alkanes. Now, a little bit of an English lesson. We have a prefix, we've talked about those. Alkanes also come with a suffix, and that suffix that tells us that it's an alkane is ane, A-N-E. Now, let's stop and think about this for a second. If we combine these prefixes with the suffix ane, you guys have actually heard of a lot of these compounds. For example, methane, 1 carbon present, okay? Meth is the prefix, ane is the suffix, methane. Methane is used, natural gas, heats our houses. Propane is fuel in barbecues. Butane is lighter fluid. And octane is essentially gasoline that we put in our cars. So you guys actually know a little bit about organic chemistry. And so now our goal is going to be to take you from what I call kind of commonplace knowledge and to jazz it up a bit and make you guys more science-y by embellishing on and elaborating on what you already know.